Yeah. So the first digit is for solids and the second digit is for water. Cool. So true or false? In zone zero in a bathroom, inside the bath or shower base, zone zero in a bathroom is inside the bath or shower, and fittings there must be SELV and IPX7. Is that true or false? So, true or false statement? Zone zero in a bathroom is inside the bath or shower base, and fittings there must be safety extra low voltage and IPX7. So, if we go back to table 6.1, we are allowed lights, but they must be IPX7 and specifically for use and SELV or PLELV supply. So luminaires and other, we are just not allowed switches or socket outlets. So only luminaires and other types of fittings and not including switchboards. So if they are protected by IPX7 and use SELV or PELV supply, they can be used inside of zone zero. It's how we get underwater lights in pools. If we go back down to the end of this section, that's where we left off. So, 1 second. Here we go. Everyone can see that screen. Should look familiar from last time. So, are these considered damp situations? So, is this a damp situation? Yes, it's a bathroom and we can clearly see a water container in there. But yeah. What about here in the kitchen? Yep, very much a damp situation. What about here? Yep, we're all in agreement. Definitely a damp situation. What about our garage workshop? Yeah, so we would not normally call it a damp situation because it is a garage workshop. And from what we can see, we can't see any water containers or any source of water. But obviously, there may be a laundry or a wash up sink involved. So the bedroom. Okay, we're all in agreement. It is not considered a damp situation. What about the wash up facility? It is definitely considered a damp situation. Cool. So again, from last week, we looked at the um, different zones of the bathroom. So we looked at zone 0 being inside a bath, the shower base, or you could call it inside the spa or pool. So basically anywhere where it's fully exposed to water and more than likely going to have full immersion. Cool. For zone 1, the area above zone 0 up to 2.25 meters vertically and directly surrounding a bath or shower. So basically the surface of the water up to a height of 2.25 meters, whether that is beyond this, unless it is broken by another surface. So what would that mean, broken by another surface? So in this situation, we're talking about zone 1. It would be a shower dome or a low ceiling. So basically, if there is a shower or a bath or a spa, but there is a shower dome or a ceiling below 2.25 meters, that's where zone 0 stops. It doesn't continue past the solid surface unless that surface is highly permeable. So it would allow the passage of steam or water. Cool. And then zone 2 is stretching zero point 0.6 meters horizontally beyond zone 1, and again up to 2.25 meters vertically, unless broken by some other surface like a shower dome or a low ceiling. And then zone 3, areas stretching 2.4 meters horizontally beyond zone 2 up to 2.25 meters vertically. So the zones stretch out to a total different distance of 3 meters beyond the edge of the water container or shower basin. So all of that is considered a zone as per 3000. So that is what we have to deal with when we're talking about the wet areas. Cool. So now we'll go back to 3000. So pools, spas, and tubs. So why are swimming pools, paddling pools, and spa pools or tubs considered high risk areas? A larger volume water, yep. Yep, they contain a lot of water, yep. Yep, there is a chance of full submersion. Yep, splashing, yep. They're considered high risk damp situations because of immersion, splashing, and often outdoor exposure. So you don't just have exposure to uh, the water and possibly chlorine in the pool as well, but you also have UV exposure and exposure to winds, which can bring debris, which if we don't have a solid objects rating can make our protection invalid. But they still have zones and they apply just like a bathroom, but they extend further. So when it talks about scope, they apply to electrical installations containing swimming pools, so a paddling pool or a wading pool, spa pools and tubs. But they do have a note here for swimming pools for medical or large commercial use. Special requirements may be necessary. In other words, a second standard needs to be used. Also classified zones. So zone 0 is still the interior of the water container for a swimming or paddling pool, and a vertical plane 2 meters from the internal rim of the water container, and the floor or surface expected to be occupied. So zone 1, a vertical plane 2 meters from the internal rim of the water container. So it extends to 2 meters. The floor or surface expected to be occupied by people. The horizontal plane 2.5 meters above the floor or the surface. And when the pool contains a diving board, springboard, etc., the vertical plane situated 1.5 meters around the diving board, springboard, and the horizontal plane 2.5 meters above the highest surface, expected to be occupied by persons. Okay, so the distances are a lot further out. Then zone 2, everything in zone 1 and the parallel vertical plane 1.5 meters external to zone 1, and the floor or surface expected to be occupied by persons, and the horizontal plane 2.5 meters above the floor or surface. So this is all well and good, but it's much easier for us to look at table 6.2. which tells us what is in. So when we talk about the zones, yeah, unless the barrier is solid, you do not include the fence. Cool. So zone 0, 1, and 2 are defined by the pool edge and water surface. It includes outdoor and indoor pools, paddling pools, learner pools, all kinds of pools that people would swim in. Cool. Requires IP rated fittings and RCDs. So there are all kinds of definitions in here, and it goes on to talk about everything required for it. So once we get past the zones, so spa pools or tubs. So a spa pool or tub with a capacity not exceeding 500 litres shall comply with the requirements of clause 6.2. So rather than 6.3, but if it exceeds 500 litres, it's classified for spa pools or tubs as set out in 6.3.2.1. So if it's less than, 5,000 litres, less than 5,000, less than 500 litres, it is considered to be needing to comply with clause 6.2 rather than 6.3. Then we go on to talk about water capacity exceeding 5,000 litres. So pretty big water container. So goes on to talk about obstacles, supplementary equipotential bonding. So where the equipment is situated in a classified zone, it is required to be earth, and all conductive parts shall be connected together by equipotential bonding conductors. So less than 500. So here, water capacity not exceeding 500 litres shall comply with the requirements of clause 6.2. So anything below 500 litres is 6.2. So that is the for the shower is the previous clause 6.3 for the bathrooms. But if it's above 500 litres, because obviously if we're above 500 litres, we need to comply with the 6.3. So if it's above 5,000 litres, it needs to comply with 6.3.2.1. And then anything not exceeding 5,000 litres are classified for spa pools. So exceeding 500 litres up to and including 5,000 litres as set out below. So zone 1 is slightly different from the pools. So you need to look at the capacity of the water container that you're dealing with and whether it is a below 500 litres or above 5,000, because that is for pools. Cool. So the swimming pools and paddling pools would normally exceed 5,000 litres. Cool. So these are specifically for spa pools. Cool. And then we will look at figures 6.15 and 16 to have a look at the examples. Make sure if you have a copy of 3000, you're following along with it in that as well. Cool. It talks about bonding. So voltage gradient. So where the equipment is in contact with the pool water, failure of insulation may result in hazardous voltages. So protective measures may include moving the electrical equipment a distance away from the pool, metal grids or barriers inserted in any plumbing connections, or the use of RCDs. So has anyone had experience working on pools or commercial or otherwise? Okay. Good. Okay, cool. So we're going to try something different. So you guys are going to be moved into breakout rooms, and then I want you guys to discuss and then report back. So if we have to take all these precautions with pools, what do you think is the best solution for installing pump equipment and electrical equipment for a pool? So basically, yeah, I want you guys to go into the breakout rooms and have a short group discussion about what you would do in the situation of having to install a new pool at a large residential facility. It's basically like a little group session. You should automatically have been put into the breakout room. Ah. Cool, sweet. So, for some reason, you guys aren't allowed into the breakout room, probably because you're not using Teams. So, we're going to have a little mini breakout room. So, discuss in the chat what you guys think is the best solution for this. Done. What do you guys think is the best solution? Yeah, so basically, if you're not using the, yeah, yeah, the pump shed, yep.
What it's saying.
Look, everyone's coming back. Right. Can everyone remember what room they were in? So room 1, what did you guys come up with? Yeah. Cool. So room 1 was Troy and Fergus at the moment. Okay. So I'll explain. So breakout rooms are basically rooms that we can, in Teams and Zooms, put you into to have group discussions in a smaller group rather than just all of you guys firing off answers at once. And so it's just a case of breaking you guys out into rooms, just so you can have small group discussions. Unfortunately, it seems that unless you're using Teams or for some reason certain people couldn't access the breakout rooms. But yeah, I know we've been using Teams for a long while now, but from the sound of things, next year they're going to be moving everything to Zoom instead, which is a little bit easier to use in a browser rather than Teams. So it'll be easier to do the breakout rooms. Cool. So So for the most part in this section, it breaks it into two categories. So pool and paddling pools are grouped together, while spa pools and tubs are given their own section. So the main difference for spas is the size. Anything over 5,000 litres gets the same treatment as a swimming pool. Smaller portable spas still need RCD protection and IP rated fittings, but the zoning rules are a little less intense. Cool. So we'll look at table 6.2. Cool. There are all these rules about it, but then the main thing to look at is 6.2. So you don't need to memorize all of the exact measurements from the standard. So we'll look at the diagrams to get an idea of how the zones are laid out. It's really the same concept we use in the bathrooms, zone 0, 1, and 2, but on a larger scale because we're dealing with swimming pools and spas. So the closer you are to the water, the stricter the requirements. So section 6.3.2 details all of the dimensions surrounding each type of pool and sizes. And you'll find how far each zone extends horizontally and vertically from the water. So much like the bath, showers, and fixed water container section, there's a lot of detail here. It is neatly summarized in table 6.2. So for socket outlets, we're not allowed them in zone 0, but in zone 1, we're not permitted for general use for pool equipment only, and there must be IPX5 and no closer than 0.45 meters to the ground and 1.25 meters away from the internal rim, or under and 0.5 meters from the edge of the fixed continuous horizontal barrier and 0.25 meters wide. And a separated supply or safety extra low voltage or protected extra low voltage or RCD protected. So it's very restrictive about how close we can have socket outlets, and they're not permitted for general use. They must be for the pool equipment. So yeah, so under 0.5 meters of the edge of the horizontal barrier. So if there's a horizontal barrier, a continuous horizontal barrier, it must be 0.5 meters below the edge, and the barrier must be 0.25 meters wide to allow for horizontal splashing. And then in zone 2, IPX4 and separate supply or SELV, PLV or RCD protected. Well, when we look at switches and accessories, not permitted in zone 0, there must be IPX5 in zone 1 and IPX4 in zone 2. So just as restrictive, but remember the distances change. Cool. Appliances, luminaires, and other equipment. So the reason we're getting into appliances is because obviously there are appliances associated with damp situations with pools and spas. So in zone 0, they're permitted, but they must be IPX8 and specifically for use, and they must either be 12 volt AC, 30 volt DC, safety extra low voltage, or protected extra low voltage supply from source outside the zone. So the source of supply cannot be within the zone. And it must have no earth. Why do you think we might not want it to have an earth? For safety, but how? Yeah, it's basically so we don't provide a return path. And it's basically saying you should make sure this equipment is double insulated. That's basically what it's saying, is you don't need an earth because it should be double insulated. Cool. And then we get into zone 1, safety extra low voltage, protective extra low voltage supply, or class 2 construction, double or reinforced insulation, or class 1 fixed in position and RCD protected. So in zone 0, it's telling us specifically to use a very low voltage and it be double insulated because it's got no earth. In zone 1, we're given the option of class 2 or fixed and RCD protected. So in zone 1 at 0, it must be both low voltage and have no earth. So it must be low voltage and double insulated. Cool, and it must be IPX5. In zone 2, we've got IPX4 and safety protected low voltage or separate supply or class 2 or class 1 and RCD protected. So it no longer needs to be fixed, but it still needs to be RCD protected. Cool, then we go down to the next section, which is heating cable systems. So why do we have an entire section for heating cable systems in this? Yeah, basically. So we don't like what would happen if you're yeah, they require more watts, so it's a bigger hazard, and because it's pretty common. So Fergus, I can't quite understand your question. Is the 0 volt. So what do you mean by the 0 volt of my DC? You're talking about the negative side of the neutral, the negative side of the DC. So the negative side of your power supply shouldn't be connected to Earth. But at the same time, what they're saying is they don't want a neutral or an Earth at the pole end. So because we're at 12 volts AC, 30 volts DC, we don't need an Earth because it's such a low voltage and we've got double insulation. So we're not creating a return path for the Earth. It's okay if it's at the board, but we don't want it in the water. That's basically what it's saying there. So yeah, the heating elements get their own section so that because they are a whole separate thing and because they're not permitted in zone 0. So they should not physically be in the water, but they are permitted. We're embedded in the floor area under the zone and protected to clause 4.10.5, which is another section. And then it's the same for zone 1 and zone 2. They're permitted. We're embedded in the floor under the zone. So they're allowed to be inside the embedded in the floor under the zone. And then obviously switchboards not permitted in any of the zones. That's just a flat, consistent rule throughout most of this, is that we're not going to put a switchboard into a damp situation. Cool. So now we'll look at a couple of the figures I talked about before. So that kind of puts it into perspective. I'm sorry, I couldn't find any colored pictures, and they didn't give me a PowerPoint for this week. Had I known they weren't going to, I would have taken the time to make my own, but I only have so much time over the weekends and during class. Cool. So as you can see, zone 0 is the water itself. That includes the pool and the little paddling pool behind it. Cool. So zone 1 is the horizontal surface, 2 meters from the edge of the pool up to 2.5 meters. But then we also have 2.5 meters above the diving. Cool. Good question. So if we have a switchboard in the laundry in a renovation, we try and move it to the wall behind the laundry. So if the laundry backs onto the hallway, we try and move it in there. Or if the laundry backs onto the exterior wall, maybe we'll put in an exterior switchboard, or we'll have to rewire it so that the switchboard is in the hallway or a new location. So if you're renovating the laundry and they want to gut the laundry and then put the laundry back in, we have to bring it up to current standards and that switchboard cannot stay. So in the event of a renovation, we need to remove that switchboard. It needs to be relocated. Best case scenario, back to back, put it into the hallway or external. Worst case scenario, we have to relocate it to the other side of the house. It all depends. No two renos are the same, but we must make it comply with the modern standards if we touch it. Have you got a situation like that you've dealing with or have dealt with? Does that answer your question, Daniel? So as long as it's not being touched, it is okay. If we are doing any major work, if we're replacing a more than 30%, I believe, of the switchboard, don't quote me on that. If you're upgrading at least 30% of the protection or replacing the protection, we have to make it comply with modern standards. Yeah, they were old. They would have been old. It would have been basically if it was compliant at the time of install or the last COC, it is considered compliant today. Because otherwise it would cause undue financial hardship on the owner. And we can't legally do that. We can tell them, if I touch this, I have to do this, and you're going to pay for it. But if you don't want to do this, don't touch it. So we cannot force a client to do an upgrade if they don't want to. But if they don't want to do the upgrade, we can't do the work they want us to do. So it's a balancing act, making sure the client understands what's going to happen if we find X, Y, and Z, and they need to be ready for it. Like I went and looked at a friend's house to upgrade their kitchen. I had a look at the switchboard, which was in the kitchen, and just said, okay, if you do this, we're going to have to do this, this, and this, and this is probably how much it's going to cost. They put off their kitchen renovation for a couple of years. Until they can afford to also rewire the house. Cool. So you'll notice in the picture, there's an extra 2.5 meters above the diving board and 1.5 meters away from the diving board, extended for zone 1. So because that diving board is higher and a person yeah. So yeah, no. Yeah, if someone can stand on the diving board, we must extend 2.5 meters above that and 1.5 meters from all sides. Realistically, if the pool was designed correctly, you doing a bomb shouldn't cause enough of a splash to do any damage to the electrical equipment. Usually at a pool, like an indoor pool, they're in a completely separate room behind a door. And if they're an external pool, they're in a external building that is protected against splashes. I think it's more a courtesy rule, but yep. And then we've got zone 2, which extends 1.5 meters beyond the edge of zone 1 horizontally and up to a height of 2.5 meters. But if you notice, the extension made on zone 1 because of the diving board does not get extended because of zone 2. I am not in charge of what you guys do outside of night class and block course. I take no responsibility for you. That's your employer's job. So yeah, that is 6.12. And then if we carry on to zone 1.3, it talks about above ground swimming pools. So again, if we look at zone 1, it extends up to 2.5 meters from the edge of the water container or the surface, and then out 2 meters, but it also extends 2.5 meters from the edge of the zone. And then we have this kind of strange angled part of the zone as well. But then zone 2 is still only 1.5 meters outside of zone 1 up to a height of 2.5 meters. So it doesn't make any real difference to zone 2 having that weird little bit, having a raised pool. Cool, and here's a top-down view. So you can see zone 0 there, zone 2. And because we have a barrier here, zone 2 stops and does not carry. Zone 1 stops at the barrier, and zone 2 does not exist beyond the barrier, except for here we have R2 and R3. So here, your R2 is R1 minus S1. So this is all about your radius extending past your zone. So just like we had in the angle, are we talking about the previous one, Connor? Yep. Okay. So with this one, because we've got the two different heights at the edge of the zone and where the zone starts with at the pool, we have to take our height from the edge of the raised pool up 2.5 meters. And then that has to meet the line that's come up from the edge of zone 1. So basically that line is just a diagonal from the 2.5 height to the 2.0. So rather than having just a hard, let's see if I can draw on the board with the pen. So, okay, come on. Yep, cool. So rather than having just like a 90-degree hard turn like that, we bring in the angle. So that way we have a continuous zone. Realistically, what I would do, for me, if I was working on this job, I would go, okay, 2.5 meters, and at the edge of zone 1, I would extend the height up to 2.5 meters plus the height of the pool. Just to be on the safe side, I would use the 2.5 meters plus the height of the pool as my maximum height for the zones. Just to be on the safe side when it comes to using this setup. Okay, cool. Yeah, it's again, these are kind of the minimum safe distances. It's up to you guys whether you go a little bit further. Like, I know this pool is in a retirement village, so more than likely the minimum safe distance is fine. There's not going to be a lot of splashing. It should be okay. Whereas if it's in a campground where there's going to be young families, lots of splashing, that one drunk uncle who likes to think he can do a massive manu, and then the actual hussy who can actually do a decent manu. So you've got to take the situation into account as well as the legal rules. So yes, this is the legal mandatory stuff, but you've also got to take the situation into account. And then, yeah, so the radius is the same as when we looked at the showers, when we have the barrier for the showers. It's basically the zone bends around the corner of that barrier. Okay. Yeah, so that's why we have these radiuses around the barriers. So in theory, just behind this barrier and this barrier here, assuming the barriers are high enough to block the zone, which they would be in at least a 2.5 meter barrier, we can put all of our gear behind the barrier as long as the zone doesn't protrude into it. Cool, so note these dimensions apply to swimming pools, paddling pools, and wading pools. So this is for fixed barriers, minimum 1.8 meters high. So there must be a minimum of 1.8 meters high to be considered a fixed barrier. Cool. So in-ground spa pools and tubs capacity not exceeding 5,000 litres. So we have only zone 1, which is 1.25 meters beyond the edge of the spa pool, up to a height of 2.5 meters. So spa pools and tubs not exceeding 5,000 litres. So if it's above 5,000 litres, it's considered a swimming pool. Has anyone had any experience with a spa pool that was bigger than 5,000 litres? I don't mean just electrically, I mean like, have you seen one? Or you think you've seen one? Swim spas, yep, swim spas are a good example. Therapy pools. I don't think indoor heated pool, I think to be considered a spa, it has to have jets. The Olympic bars in Auckland, oh yeah. I mean, I even think like your local swimming pool, they've got one of those big bubbly spa pools where more than 5 or 6 people can sit in them. I think those are above 5,000 litres. So if anyone's been to the one in Porirua before, I'm pretty sure the adult spa pool there is bigger than 5,000 litres. Yeah, there's always going to be kind of an exception to the rule. So yeah, again, dimensions all in meters. And then here we go for a above ground spa pool and tub not exceeding 5,000 litres. So this is above ground. So again, we have the weird angled part from the top edge of the water container out to the edge of the zone. This is because of that difference in height. But again, me personally, I would go 2.5 meters plus the height of the spa all the way up to the zone because it's going to be easier math. Cool, and then we go into fountains and water features. Cool, so water features. So what are the risks, do you think, with water features or things like ornamental ponds? And in this case, we're not talking about a bidet. I spoke with my colleagues. They can't break. I spoke with my colleagues. A bidet does not count as a water feature because there is usually a fixed barrier either in yourself or the toilet seat. Yep, splashing and spraying, not necessarily UV. So they're often decorative but pose the same electrical hazards because they usually contain submersible pumps and lights. So they usually have direct immersion issues. And they're usually in public areas, so there's a higher risk of contact. So just because it's decorative doesn't make it safe. A fountain or pond still has water, splashing, and people nearby. That means it gets the same attention in the wiring rules as bars. So we go down to the next section. it talks about fountains and water features. So they apply to the electrical installations associated with water containers of fountains and water features and the surrounding zones. So they're based on the classification of zones surrounding water containers. They're intended to protect electrical material and equipment from the corrosive effects of chemicals used in the treatment of water in the fountains and water features. So encounter the increased risk of using electrical equipment in areas where the body may be partially immersed. So you've got to remember, if these things are out in the public area, they've normally got chemicals in them to treat them. So what kind of chemicals would we be expecting in this kind of water? Chlorine, yeah. That's one option. Fluoride, mind you, that's in the water anyway, the drinking water. Close enough. So there's one other one, a cheap alternative to chlorine that people might substitute because they can't get their hold on it. Salt? No, not salt. Salt is a good one though. You would normally use it to keep your clothes nice and white. Yeah, bleach. Believe it or not, a lot of people, when they can't get chlorine for their water or they think it's too expensive, hydrogen peroxide and bleach. Just because sometimes it's easy to get their hands on. So just be aware that may be in the water that you're dealing with as well as possibly chlorine. So these requirements need not apply to fountains or water features where the depth of water does not exceed 0.3 meters. So if it's less than 300 mil deep, the requirements do not apply, or it has a suitable means to restrict entry of persons to the water. So it is in a sealed container or it is sealed so that people cannot get into it. Oh, and then it talks about the zones. So zone 0, again, the interior of the water container, that's pretty much a constant throughout this entire section. Zone 1 is vertical plane 2 meters from the internal rim and 2.5 meters horizontally across the floor or surface. So kind of similar to pools. And then when the fountain or water feature contains sculptures and decorative water containers, it's the vertical plane situated 1.5 meters around the sculpture and decorative water containers, and the horizontal plane 2.5 meters above the sculptures and decorative water containers. So we'll have a look at some of the features later. Cool. So again, it talks about SELV and in accordance with clause 7.5.5. Supply, it shall be earthed and protected by an RCD, not exceeding 30 milliamps, or supplied at extra low voltage through an isolating transformer, or supplied by other suitable measures to take contact of electrical equipment, methods, and physical location. Cool. So it talks about some prohibited measures, degree of protection is required, talks about all the socket outlets, but again, there should be, there's no table for this one. So we have to kind of just go with follow the directions. So it doesn't say we can't have, so in zone 0, again, IPX8 and 5 socket outlets not permitted in zone 0 or 1. There is no zone 2. So switches and sockets, not installed in zone 0. And zone 1 shall be with the required degree of protection. So IPX8, IPX5. Luminaires, zone 0, design and construction for that use, and provided with the IPX8 zone 0 protection. And it's kind of the same as the ones we've read before, but again, no switchboards in any of the classified zones. So we'll look at, so 6.4.2 is the classified zones, and then we must read through 6.4.4 to ascertain the information of the fittings in each zone. It unfortunately does not give us a table for for this. Oh, so figure 6.17. So this is the determination of the zones of a fountain. So if you see, we've got 3 different pools. So if you imagine this is a 3-tier pool. So we've got your top one, your second one, and your third. And the third one also has a sprouting water feature. So each of the bodies of water are considered a zone 0. And then zone 1 extends 2 meters beyond the edge of each of those water containers and behind it as well. So on all sides. So that's a vertical. And then if we go and look at that same one horizontally, so again, 2.5 meters above each container and 1.5 meters horizontally. And then where it has the sprouting water feature, 2.5 meters above the edge and 2 meters beyond. So because that bottom one has a actual water feature and is not a fountain, it needs the zones to be extended. Does that make sense? Please fire some questions at me. I know more than likely a lot of you guys won't come across stuff like this, but it is still necessary for you guys to know about it because they may ask you a question about it in your regs exam in year 3. It might be, how far away from zone 0 of a fountain can I install a socket outlet or a IPX6 luminaire? All kinds of things like that. Cool. So some key takeaways. So water features. Yep. Yes. If it asks you a question about it, they should supply you with a excerpt from the regs. Cool. How big's the pool, Andy? I know yet. Okay, well, you have to let us know and send us some pictures as it progresses. So water features, they follow the same zoning principles as pools and spas. It's just the containers are a little bit different. So anything inside the water, safety extra low voltage, IPX8. Anything around the water, splash, jet, and jet resistant, and RCD protected. Decorative doesn't mean exempt. The risks are the same. Just because it's pretty doesn't mean it gets passed. Cool. So saunas, the purpose. Cool. So saunas. So what is a sauna? Never, that seems like a silly question, but what would you classify as a sauna? A big steam room, yeah. A steam room, yeah. Hot steam room, yeah. Yeah. Yeah, as far as 3000 is concerned, it's electrical equipment in rooms or enclosures containing heating equipment used exclusively for sauna heating. So a sauna is basically a room that is designed to be heated, whether that includes steam or not. Sometimes they do not. Steam is just an effective way of getting the heat around the room and into the body. Oh, so what are the potential hazards with a sauna? Heat, yep. Asphyxiation, yes. Especially if you're in the movie Hitman. The ambient temp, yep. Current rating, dehydration, yep. Moisture ingress, condensation, yep. Like in these answers. High humidity for sure. Yeah. So some of the hazards to address are things like high humidity and temperature, which can cause a rapid deterioration of normal equipment. So we can't use standard equipment. The heat can cause insulation breakdown, which can lead to component failure or fire. So the rules are about temperature tolerance rather than water splashing. So yes, there is steam, but it's not splashing or jets. It's more about the temperature tolerance than anything else. So unlike bathrooms or pools, saunas don't just have moisture to deal with, they have extreme heat. So that's why the wiring rules uses zones here too, but instead of water zones, these ones are based on how close you are to the heater and how hot it gets. So when we talk about zone 1, so it's the area containing the heater, limited by the vertical plane 0.5 meters from the external edge of the sauna heater, and the floor or surface expected to be occupied by persons, and the cold side of the thermal insulation of the ceiling. So, zone 1 is around the sauna heater, up to a vertical plane of 0.5 meters from the heater's edge, from the floor up to the ceiling's cold side of the insulation. Zone 2, limited by vertical plane, limiting zone 1, cold side of the thermal insulation, and floor or surface expected to be occupied by persons, the horizontal plane 1 meter above the floor. Cool. So between zone 1 and the insulated wall surfaces, from the floor up to 1 meters above the floor. So no special heat resistance required for electrical equipment in this zone. And zone 3 is the upper sauna area. Vertical plane limiting zone 1 and cold side of thermal insulation. Horizontal plane 1 meter from the floor to the cold side. So zone 3 is directly above zone 2. So it's from the top of zone 2 to the ceiling, and our equipment must withstand 125 degrees C with conductor insulation rated at 170 degrees C. So if we go down here, so the following protection of electric shock shall be prohibited. So all equipment should be protected by an RCD with a fixed rated current of residual current of 30 milliamps. So the equipment shall have a degree of protection of at least IPX4B or IP24. So zone 1, only electrical equipment belonging to the sauna heater itself is permitted in zone 1. Zone 2, no special requirements concerning heat resistance of electrical equipment. But zone 3, it shall be suitable to withstand a minimum temp of 125 degrees C and the conductor insulation up to a minimum of 170 degrees C. So some pretty high temperatures that we're dealing with inside the sauna. So yeah, all equipment in the sauna must be protected by RCD. It must be IPX4B or 24. And socket outlet switches and accessories are not permitted inside the sauna except those built into the sauna heater itself. Cool. So it should be installed outside the zones, the wiring systems. So yeah, so the exception is for accessories that form part of the sauna heater for socket outlets. The heating appliances shall be installed with the manufacturer's instructions. And again, a switchboard shall not be installed within any classified zone. That is B for the IP rating. IPX. No, I'm not 100% sure what the B means. Yeah, trying to find some answers. So it is an optional after letter that could mean a few things. Yeah, I think it's related to heating equipment, so it's designed to take the temperature. So I'm going to go with it's for a heat rating rather than a like ingress protection. It's made to withstand a certain amount of heat. But then we can go and have a look at the zones. So if we can see zone 1 here is specifically the sauna to 5 meters past the sauna up to the ceiling. Cool. You've got zone 2, which is here where people are likely to sit, and zone 3. So if I was to place a standard LED downlight in zone 3 of a sauna, what could happen? Burnout, yep. Steam ingress. Appendix G. Okay. I'm going to look that up on my phone rather than. Yeah. So IPX4B. The B stands for S finger penetration to a maximum of 80 millimeters, must not contact hazardous parts. So basically, I can stick my finger in 80 millimeters and not be in contact with hazardous parts. Yeah, I never would have thought of it being accessed with finger. But cool. We all learned something tonight. Thanks, guys. Cool. So yeah, if I was to place an LED downlight in zone 3, it would cook itself. It was a standard downlight. So why is zone 3 have a temperature requirement, but zone 2 does not? Why does zone 3 have a temperature requirement? Yeah. So yeah, basically, as we cause the sauna to heat up, heat will rise. So basically, we the people are all chilling out down here, whereas in the meantime, that heat or the steam that we're throwing on there is rising and it's just collecting up in the zone 3 area, heating up whatever thing we've mounted in that zone. So yeah, that is why zone 3 has more temperature requirements than zone 2. And then here, a horizontal view. So again, 0.5 meters, anywhere from the edge of the box. And again, the corner creates a radius, not a hard edge, but it would be easier just to measure 0.5 out. Don't put anything in this side of the room. Again, zone 2, the lower walls up to 1 meter high are less restrictive. But again, once we get into zone 3, we need to be worrying about insulation ratings and thermal ratings. But anywhere that we mount anything, it must be RCD protected, which are quite dangerous because you can now buy saunas in a box that plug into an outdoor power point. So, refrigeration rooms. So, when we talk about refrigeration rooms, we're talking about freezers or cold rooms. Because of the nature of the locations, we need certain extra methods. So the use of safety extra low voltage is used, and prohibited measures, selection and installation of equipment. So what are the hazards that we can think of with refrigeration rooms to our electrical equipment? Condensation, yeah. Yeah, temperature. It's going to get pretty cold in that room. Temperature, cold, moisture, yeah. Yeah, if you guys ever want to do a fun experiment, take a piece of scrap TPS, a short piece, and put it in your freezer for about a week, and then see what happens when you pull it out. There is an essence of mechanical damage because depending on the cool room or freezer situation, there could be like, if, for example, it's the freezing works, stacking boxes, or meat carcasses, meat hooks, that kind of thing. We're also talking about like giant refrigerant gas pipes, yeah, giant refrigeration warehouses. Yeah, there's potential of like forklift damage, just like any commercial business or warehouse. So, so condensation is our main issue. So electrical equipment does not like coming into contact with cold, moist air. So water droplets form on surfaces and can drip into the enclosures, or they can freeze inside of the equipment, forcing it to expand. Cool. So it leads to reduced insulation resistance. because we've got that moisture buildup. It corrodes terminals and tracking and possible short circuits. So the water can track along the cables and then bridge between, say, phase and neutral or phase and earth. Cool. So they're tricky because of the condensation. So if we think about a cold beer on a hot day or a nice glass of LMP, water forms on the surface of the glass. The same thing happens to electrical gear inside of a chiller. Warm components meet cold, damp air, and suddenly you've got moisture dripping into places it shouldn't. Add in hose down cleaning, and you've got a very hostile environment for electrical fittings. So, our wiring enclosures or wiring systems must prevent moisture from entry into the enclosures and conduits. So, degree of protection required. So, installed within the refrigeration room shall be protection of at least IPX4B or IP24. There's also 6.7 regard to sanitization hosing down. We'll talk about that. So our wiring systems should not be affected by the operating temperature of the room. It does not provide pockets or channels in which moisture can accumulate. So types permitted. The following wiring types are permitted. Unenclosed sheathed cables, including served MIMS cables, insulated, unsheathed, or sheathed cables enclosed in a wiring enclosure that has adequate draining facilities. So we need to allow for drainage of our wiring enclosures and any other wiring systems that are not inferior to the systems described in A or B. So we go for non-hygroscopic insulating materials to be preferred. So why are we having unenclosed sheath cables, including served MIMS cables? So unenclosed and sheathed, the sheathing is its own type of kind of extra insulation. So remember, mineral insulated metal sheath cables have a layer of insulation inside the sheath, which will help protect against it. Yeah, exactly. So served MIMS cable has an extra layer, so it will be covered in an extra layer of protection. So including served MIMS cable, so it will have almost like a lacquer over to prevent the copper from expanding and contracting too much. Yes, they do. New boiler rooms. Obviously, you still come across it in MIMS elements in your hot water cylinder and your stoves, but yep, they still do install MIMS cable. The best application for it is in petrol stations. It's also known as pyro. Yeah, it's good for gas stations because it can handle um, the environment. Old motel mains? Yeah, fair enough. Cool. So yeah, so luminaires or our light fittings. So yeah, each wiring enclosure as it passes from a refrigerator to non shall be sealed with a compound that does not set hard. point of entry cables into motors, luminaires, switches, or other electrical equipment. So why do we want a compound that is not set hard? Yep. Nail on the head. Thermal and expansion and contraction. Yep. So I don't know a good name for here. Yeah, room to expand. So yeah, it can move as things expand and contract. One good one they have over in the States is called Big Stretch. And a lot of silicon is, or what they call it, cork, is designed to not completely set hard, so it can still have a little bit of springiness. So you need to make sure it's not a compound that will set hard. Cool. So our luminaires must be sealed against moisture ingress, and we must use types designed for low temperature and damp condition. So we need to make sure we're using the correct fittings. Most of the time, the guys who build the cool rooms will do that themselves. So basically, does anyone know what an EST is? Yep, an electrical service technician. So most of the refrigeration guys also get their. No, toaster mechanic is an electrical appliance service person, not a service technician. So most service technicians are, refrigeration guys are also service technicians, so they can do their own connect and disconnect. And if they build cool rooms, they usually do all of the electrical stuff for you, and you just provide them with a cable to connect into their equipment. The really good ones will run the cable back to the switchboard, but not connect it for you, and they will let you basically just do the connection and charge $250, or at least that's what I do. Oh wait, that's on record. Shit. All good. Cool. So socket outlets, they must be moisture resistant or IP rated. So IPX4 or higher, and the placement should minimize risk of direct water spray or condensation of moisture. Cool. And the general, all fittings and accessories should be corrosion resistant and protected against both moisture and cleaning products. So why do we want them to be corrosion resistant? Yeah, to stop corrosion. So basically, they're going to be exposed to a lot of moisture and condensation. So they need to be corrosion resistant, but also whatever chemicals they use in the refrigerant, it may escape at some point and get released into the air, or whatever chemicals they use to wash down the facility might be quite corrosive as well. So we want to be able to resist that corrosion. So yeah, fixed appliances shall be designed for the location and conditions. Cool. And then heating elements in the door seal. So one thing that happens with refrigeration rooms is that they will have a heating element in the door seal. Why do you think they have a heating element in the door seal? Yeah, so basically, so it doesn't freeze shut. It's also to protect the rubber that seals the door. I'm not sure where you're going with that, but yeah, so basically it's to keep the door seal from freezing shut, and also the door seal over time, if it is exposed to too much cold air, will deteriorate and start to crack, and so it means more frequent replacement. So that's why the doors seals are normally heated to prevent that. Prolongs the life of the seal and also means that it can't be frozen shut. Obviously, because it's a refrigeration room, people are going to be in it. So it's a bigger issue if it freezes shut. Cool. So some key takeaways. So condensation equals warm electrical gear plus cold moist air, which leads to moisture problems. So refrigeration rooms are constant damp environments with added cleaning hazards. So the wiring systems must be installed to avoid condensation inside the conduits, as per clause 6.6.4.2.2. Oh, that's a mouthful. Luminaires and sockets must be sealed, IP rated, and suitable for moisture exposure. And all equipment must be corrosion resistant at the very least and RCD protected. So we'll have a quick run through of sanitization and general hosing down operations. So the hazards, so areas like cow sheds, food processing plants, and even commercial kitchens are subject to regular cleaning with hoses or sprays, and high pressure water jets can force moisture into equipment. Cleaning solutions often containing chemicals that accelerate corrosion. There are also certain areas inside hospitals that are washdown areas, as well as chemical plants and places that deal with toxic waste. So you've always got to be aware if you're dealing with a washdown area, the risks involved. And the cleaning, yeah, so in sanitizing areas and hose down areas, we're not just dealing with splashing water. These spaces are cleaned with low or high pressure hoses, sometimes using strong chemical solutions. It means fittings need to be tough, both water resistant and corrosion resistant, to survive. Cool. So our electrical equipment must be suitable for the cleaning method used. So zone. So there are zones. They're based on dimensions and limits of any location likely to be affected by hosing in the following ways. So where it's limited to the floor, to a horizontal plane 2 meters above the floor and any wall within the area, and any location on a ceiling that is within 1 meter of a wall within the area. And where it's limited to the floor only, the classified zone consists of floor and walls, and where floor only, it's to 1 meter above the floor. Cool. So we go. Degree of protection. So it must be IPX5 where we use low or medium pressure hosing down. But anywhere where there is high pressure, we need IPX6. That's as per requirement clause 6.7.4.2. Cool. Cool. Switchboards installed in classified zones and location subject to sanitization or hosing down operations shall be provided with a minimum degree of protection of IPX6. So this is the only place where we can install a switchboard, and the equipment, including the wiring system, shall be of a type that won't be affected by the method of hosing, materials used, the temperatures and the pressure, protected against moisture accumulation, and doesn't provide channels or pockets which moisture might pass into the electrical equipment. So clause 6.7.4.3 spells it out. The electrical equipment, including the wiring system, will not be affected by the method of hosing, the materials used, or pressure of the hosing medium. The equipment must be protected against moisture that can accumulate and not provide anywhere where moisture might pass into the electrical equipment. Cool. So there are no pictures, unfortunately. So for the hosing down areas, remember, exposure to frequent water jetting and chemicals is what this means. So if it's considered a sanitizing or hose down area, it means it'll have frequent water jetting and chemicals. So electrical equipment must be fit for these cleaning methods with a minimum of IPX5 for low pressure and medium pressure and IPX6 for high pressure. And all the fittings must be corrosion resistant. Oh, so there is quite a requirement for bonding for wet areas. Because we obviously metal is going to be exposed to moisture, we need to make sure that it is bonded correctly. So in dry areas, you might get away with small differences in potential, but in bathrooms and pools, the human body's resistance is lower because of the added moisture. So even a small voltage difference can be deadly. So equipotential bonding is our way of making sure everything you touch has the same potential. So we actually have to drop. So what is the maximum allowable resistance for our bonding conductors? What's the maximum allowable resistance for a bonding conductor? If we jump to, sorry, it's going to, section 5.3. For equipotential bonding. Oh, where is it that it actually says it? So it is 0.5 ohms. I am trying to find where it actually says it. I think it might be in the verification section. Yeah, but it is 0.5 ohms. For the main earthing conductor and the bonding conductor, it needs to be 0.5 ohms. Too far. And if we go to 6.3, back to the bathroom. So when we're talking about a pool, what needs to be bonded? Is it? Sorry, I can't find it. So basically, metallic water pipes. So any water pipes for the pool. Structural steel reinforcement in floors and walls, if exposed or accessible, and metallic fittings and enclosures within the zones. So baths, shower frames. So okay, I'm in the wrong section. So 6.3.4.2. Cool. So yeah, we need bonding of conductive fittings where necessary, and bonding required between pool structures, reinforcing steel conductive fittings, and surrounding conductive parts. So there is a lot of stuff that needs bonding when we talk about pools. You should always bond the steel and the reinforcement in the pool, because if the water cracks, if the pool cracks and water starts to pool around the reinforcing steel and somehow that becomes live, it can lead to shocks. So remember, the higher risks are due to the reduced body resistance in damp areas. So 5.6 bonding conductors, 0.5 ohms, and mechanically sound. We need to bond metal pipes, fittings, structures, and enclosures. Bathrooms, pipes, baths, and fittings. Pool structures, reinforcing steel and conductive fittings, and surrounds. I am reading off the basically the lesson plan they give us, which is not for public use, but clause 5.6 is for the bonding conductors, and bathrooms 6.3.4.2.4, and for the pools 6.3.4.5. I think they used I fucking AI for this shit, didn't they? So yeah, they aren't. But basically, N3000, we do need to earth any metallic pipes, baths, or fittings when do we not need to earth pipes, baths, and fittings? Yeah, basically when they're non-conductive. So if we've got PEX pipe or PVC pipe or butylene pipe, we do not need to bond it. If the bath is made of ceramic and is not metal, we do not need to bond it. If the fittings are non-metallic, we don't need to bond it. But also if it's not connected to any metal piping, we don't need to bond it. Or if all of our circuits in the bathroom are connected to RCD. For the pools, we're always going to bond the reinforcing steel and any conductive fittings. It's more than likely that they're going to be metal stairs or metal steps into the pool, but sometimes they're fiberglass. I would prefer to have fiberglass personally. And any metal surrounds, most of the time they go for non-conductive options, as to generally they last a bit longer than their metal counterparts. Oh, so what is extra low voltage? You won't find it. Nah, I forgot. Cool. So we won't actually find it in 3000. So extra low voltage is 50 volts AC or 120 volts ripple free DC. So we use it to reduce the risk of electric shock by using low voltage. It's generally not harmful. So we have two types, SELV and PELV. So when we can't rely on ordinary circuit protection, we have to take a different approach. So that's where we use SELV or PELV. So the extra low voltage systems that are designed to be inherently safe, even in damp or wet conditions. So SELV stands for separated extra low voltage. So what do we mean by separated extra low voltage? So yeah, it is a system supplied from a safety isolating transformer or equivalent source with no connection to earth or other circuits. So it's fully isolated from the main supply, it's insulated and physically separated from all other circuits, and it has no earth reference. So it has a reduced risk of fault current flowing through a person. So normal applications, shaver sockets in bathrooms, lighting inside pools is normally from a transformer outside of the pool, toys and small appliances. So what about PELV? What is protected extra low voltage? Or protective extra low voltage. Yeah. So it is an ELV system where the secondary is connected to earth. So it has an earth connection for fault clearance, but it provides a similar shock protection to separated extra low voltage, but allows protected devices to operate under fault conditions. So applications would be your control circuits in industrial settings, certain damp area fittings where earth reference is beneficial. So all of these must comply with clause 7.4. So the requirements include that it's separated from the low voltage circuit by physical barrier or double insulation. It must be identified as extra low voltage. We must ensure correct transformers are used. So if it's a transformer, it's an isolating transformer. And only circuits intended for SELV or PELV may be connected to those systems. So we'll wrap things up. So what is a damp situation according to 3000? This will more than likely be one of the questions you get asked as part of your end of unit assessment. But what is the 3000 definition? Yep. So a damp situation is a location where moisture is permanently or intermittently present in a way that could compromise electrical safety. So ASNZS 3000, section 6. How do zones in bathrooms differ from zones in saunas? Yep. So the main difference between the zones in a bathroom versus a sauna. So bathrooms, they're defined around the baths and showers and the fixed water containers, with restrictions tightening closer to the water source. Whereas the sauna, the zones are based on proximity to the heater and the temperature exposure. So that's why we have the zone 3 at the ceiling height, because that's where the heat collects. So why might PVC wiring systems not be suitable in refrigeration rooms below freezing point? Yep. So because of the low temperature, the PVC cable can become brittle, increasing the risk of cracking and insulation failure when exposed to cold, moist conditions. And what cable must we use inside of the walls of the refrigeration room, which are filled with polystyrene? Yep. We must use non-migratory cable. So that way the plastic doesn't get eaten away into the insulation. Cool. So what does SLV stand for, and where might you use it? Remember, it's not safety, it's another word. Yep. So separated extra low voltage. So it's isolated from the earth and it's used in shaver sockets, toys, bathroom fittings, lights, landscaping lights, all that kind of stuff. And so what is PELV? And what is the difference between PELV and SELV? Yeah, so the main difference is that the PELV has an earth. Yeah.